Hi class, so we're going to revisit 9.1.6. From my understanding, some of you guys are having a difficult time understanding what is being asked and how to go about solving these problems. So I just want to come back here and look at what we can do to help you understand. So first off, right, the objective here, once again, is for us to use our knowledge of special triangles and reference angles to label the exact values of the coordinates on a unit circle. A unit circle being a circle with a radius of 1, and we did an example of walking through converting degrees to radians or converting radians to degrees, and so if you need that refresher, you're welcome to go back to Google Classroom or find the other video, prior video, to see how I worked those problems. But coming down to 72. So 72 says there are some angles for which you know the exact values of sine and cosine. In other words, you can write the exact sine and cosine without using a calculator. Work with your team to list as many such angles expressed in radians as we can. Now, radians, because it is a newer topic, it is a little harder for you to maybe right away make a correlation of where these measurements are, and I don't expect you to know those just yet, where the different radians are. But you do have some special right triangles. Because remember, if we have our unit circle with our radius 1, within this unit circle, we are able to draw right triangles. And a couple of right triangles we do know special properties are 30, 60, 90 triangles and 45, 45, 90 triangles. So let's just focus on these two triangles right at the moment. So let's draw a 30, 60, 90 triangle. Of course, not to scale. But if we were to say this is a 30, 60, 90 triangle, one thing we might ask is, well, if this is 30 degrees, what would it be in radians? Right? Because we are being asked to work with the team to list as many such angles expressed in radians as we can. So we can be looking at 30, 60, 90 triangle, but how many radians is this? Well, to convert that, right, we got 30 degrees, and we can multiply pi over 180 degrees, and that simplifies to 30 pi over 180 degrees, right? The degrees are going to cancel each other out, and then as we simplify this a little further, we get this to be pi 6 radians. So 30 degrees is equal to pi 6 radians. Now in this 30, 60, 90 triangle, we know our hypotenuse is 1. And if we remember some special properties from a 30, 60, 90 triangle, well, if we have a x, we could have like a 2x, and then this would be the square root of 3 times x. And so then whatever x is, we are able to make some quick calculations from. And we know in our case, though, that this is 1, right? So 2x is equal to 1. Therefore, right, if 2x is equal to 1, x must be 1/2. Therefore, we can start labeling certain parts of this triangle. Let me just copy this triangle so we can reuse what we are seeing, and let's just paste this down here, and so as we've previously stated, this is 1, and it looks like we just moved it, not copied, so I apologize for that. But we know this is 1, this was x, while this was 2x, and so this should be half of that, so this will be 1/2, and this was x times the square root of 3, and x is 1/2, so this is x times the square root of 3, or we can rewrite that as the square root of 3 over 2 if we multiply those together. So if we're looking on a unit circle, once again, let's just say this is a 30, 60, 90, even though this is more drawn as a 45, 45, 90. We can look at our x and y axis, our coordinate points of where this radius is on the circle, where the termination point. And so we see our x value is the square root of 3 over 2. So we can list that as the square root of 3 over 2. And our height, if we remember, is 1/2. So that's 1/2. So that's when we're at pi 6 radians. And so if we were to make a table, we could say pi 6 radians, and we're being asked, once again, going back to what we're initially being asked about, exact sine and cosine without using a calculator. So if we write cosine and sine, okay, well, at pi 6, we are at square root of 3 over 2, and sine is 1/2. Right, so this is in radians. And now if we did something similar for 45, 45, 90 triangle, first, once again, we would want to convert it like we did over here to find how many radians we have. And if we convert 45 degrees by multiplying it by pi over 180 degrees, this is all going to simplify down to pi fourths. And so I'm going to put pi fourths over here. And we want to find what our x values are. So what is our x and y value for a 45, 45, 90 triangle, or for a pi fourths measurement? So what we can be looking at now is drawing a 45, 45, 90 triangle. And we know our radius is 1. Now something to help us out here, right? So this is so not drawn to scale, but we know that this is x, x, and x times the square root of 2 typically for 45, 45, 90. That being said, we only have a 1 here. And so we can ask ourselves, well, what are the sides going to be? And so there's a couple ways we can go about looking at this and trying to solve it. One way that I'm going to do is I'm just going to label both of these x and use Pythagorean theorem, and I know x squared plus x squared should give me c squared, well, and that's just going to be 1. I can combine these and I can get 2x squared is equal to 1, or x squared is equal to 1/2, or x is equal to 1 over the square root of 2. And so that would be what x is equal to. Now, oftentimes when you have a radical in the denominator, that is not something that we like to see, and so a lot of math teachers will tell you to what's called rationalize the denominator. And so I'll take that 1 over the square root of 2 and I'll multiply it by a fancy 1, and that fancy 1 will be the square root of 2 over the square root of 2, which now I can then rewrite as the square root of 2 over 2. Those are the same thing, and this square root of 2 over 2 is going to be a more appropriate way to write it, so a way you'll see it more. And so that's your x and y value. And so I will just come over here and write square root of 2 over 2 and square root of 2 over 2. Remember, cosine of theta is my x's, sine of theta is my y's. Now, that being said, I could squeeze in one more thing. Let's see if I can insert some more space down here. So I want to go back to this 30, 60, 90 triangle. So we have a 30, 60, 90 triangle, 45, 45, 90 triangle. But we can also look at a 60, 30, 90 triangle within the unit circle. And so, so if we do a quick conversion to determine our radian, get out of the degree mode, get into that radian mode, right, we'll multiply by pi over 180 degrees, and this would simplify to pi thirds. And so pi thirds is what I'd write there. And then I want you to think for a moment, what would be my x value, what would be my y value. So hopefully you're thinking, well, this is a 30, 60, 90 triangle, and this is also a 30, 60, 90 triangle. It's just oriented a little different. And so my x value is going to be 1/2, while my y value over here is 1/2. Therefore, my y value down here will be the square root of 3 over 2. And so as far as writing some exact values for some angles, which we do know, this is what we can do. We didn't have to use a calculator. We did have to make some minor calculations, but none of those calculations we had to use a calculator for. And I think we'll end there, and then I'll make another video here on 73 a little bit, because I only have a couple minutes, so I don't want to run into that next one. So I'm going to stop this one and start a new one.